Dear students, in previous lecture we have studied nth root of complex number and we have studied how De Moivre's theorem is helpful to find nth root of given complex number. In this lecture we will study special case of it, nth root of unity. Unity means 1. Unity means 1. Okay. And its properties. Okay. So W is nth root of unity that is of 1 if W raised to n is equal to 1. Here 1 is equal to cos 0 plus I sin 0, which is equal to cos of 2 pi k plus I sin 2 pi k for any k belongs to Z. Therefore 1 raised to 1 by n is equal to 2 cos pi k plus I sin 2 pi k raised to 1 by n is equal to 2 cos 2 pi k upon n plus I sin 2 pi k upon n, k equal to 0, 1, 2 dot up to n minus 1 gives nth roots of unity. Here Wk raised to n is 1 for every k equal to 0, 1, 2 up to n minus 1. Is it right? So moreover W naught is equal to cos 0 plus I sin 0 is equal to 1, which is equal to W. W1 is equal to cos of pi plus I sin, okay, this is your 1. Now W1 is equal to cos pi plus cos of pi by n plus I sin pi by n. We will denote this by W1. W2 is equal to cos of 2 pi upon n plus I sin 2 pi upon n, which is equal to W square, and so on. Wn minus 1 is equal to cos of n minus 1 pi upon n plus I sin n minus 1 upon n is equal to W raised to n minus 1. Therefore W naught is equal to W, W1 is equal to W square, W naught is equal to 1, W1 is equal to W, W1 2 is equal to W square, and so on. Wn minus 1 is equal to W raised to n minus 1, or n distinct nth roots of unities. unity. Result 1 plus w square plus dot dot up to w raised to n minus 1 is equal to 1 minus w raised to n upon 1 minus w, which is equal to 1 minus 1 is upon 1 minus w is equal to 0. Okay, that is sum of nth roots of unities is 0. Their sum must be 0. Okay. Second, they are in geometric progression. Second result, 1 w square dot dot up to w raised to n minus 1 are in geometric progression. With ratio w. Nth roots of unities are in geometric progression. Okay. We'll see now application of this. Solve the equation z raised to 6 plus I equal to 0. Z raised to 6 plus I equal to 0. Solution, z raised to 6 plus I equal to 0 implies z raised to 6 is equal to minus I. So I can write this as minus I. Minus I lies on negative. What is the angle made by this one? Minus I is here. So what is this angle? This angle is 3 pi by 2. So here mod of minus I is equal to 1 and is equal to R. Theta is equal to argument of minus I is equal to 3 pi by 2. 3 pi by 2. Is it clear? And therefore z raised to 6 is equal to minus I, which is equal to cos of 3 pi by 2 plus I sin 3 pi by 2. Right? Which is equal to cos of 3 pi by 2 plus 2 pi k plus I times sin of 3 pi by 2 plus 2 pi k. K belongs to Z. and therefore z is equal to minus I raised to 1 by 6 is equal to, what will get, cos of, this is nothing but 3 pi plus 4 pi k upon 2 plus I times sine of 3 pi plus 4 pi k upon 2 raised to 1 by 6. So by De Moivre's theorem, we will get this to be cos of 3 pi plus 4 pi k upon 2 into 6, that is 12, plus I times sine of 3 pi plus 4 pi k upon 12. K belongs to Z. For k equal to 0, 1, 2 up to 5, we get Z0, Z1, Z2, Z3, Z4, Z5 as follows. As Z0 is equal to, what is your Z0? Cos of 3 pi by 12 plus I sin 3 pi by 12. That is cos, if I put here k equal to 0, we will get 3 pi by 12 cos of pi by 4 plus I sin pi by 4. Right? What is it? Cos pi by 4 plus I sin pi by 4. It is nothing but 1 plus I by root 2. 1 plus I by root 2. Oh, how we are getting it to k equal to 0, Z1 is equal to, if I put now 1, what will get? 3 pi plus 4 pi, 7 pi by 12 plus I sin 7 pi by 12 and so on. Okay. So thus we will get six solutions for that equation. 6 solutions for that equation. Okay. Z5. Next example. Prove that minus 1 plus I raised to 7 is equal to minus 8 into 1 plus I. One plus I raised to 7 is equal to minus 8 into 1 plus I. Solution. Minus 1 plus I implies mod z is equal to r is equal to under root of minus 1 square plus 1 square is equal to root 2. root 2. Theta is equal to argument of z is equal to tan inverse of 1 upon minus 1. Minus 1 plus I. X is minus 1. I is here. So we will get this one. So this angle, that is pi by 2 plus pi by 4. Which is equal to, you have to multiply this by 2, 3 pi by 4. 3 pi by 4. Is it clear? So therefore, minus 1 plus I is equal to root 2 into cos of 3 pi by 4 plus I sin 3 pi by 4. Okay. And therefore minus 1 plus I raised to 7 is equal to root 2 raised to 7 into cos of 3 pi by 4 plus I sin 3 pi by 4 raised to 7, which is equal to root 2 raised to 7. So root 2 raised to 6 into root 2. Cos of 21 pi by 4 plus I sin 21 pi by 4 by De Moivre's theorem. This is your 8 into root 2 into cos of what will get here? Six pi minus 3 pi by 4 plus I sin 6 pi minus 3 pi by 4, right, which is equal to 8 times root 2 into cos of 3 pi by 4 minus plus I sin minus 3 pi by 4. Since cos and sin are periodic function with period 2 pi, cos of minus theta is cos theta, sin of minus theta is minus sin theta. So we will get 8 root 2 into cos of 3 pi by 4 minus I sin 3 pi by 4 minus 3 pi by 4 angle. This is pi by 2. This is minus 3 pi by 4. So this is minus 1 plus I by root 2. Okay. So this is nothing but 8 root 2 into minus 1 minus I by root 2, which is equal to root 2 get cancelled, minus 8 into 1 plus I. Okay. So left hand side, okay, is equal to right hand side. Thus minus 1 plus I raised to 7 is equal to minus 8 into 1 plus I. So with the discussion, We'll stop our lecture here. Go through the examples from exercises. Solve examples on your own. If you have any difficulty, you can ask personally to me. And hereby I am declaring that our complex number chapter is over here. It remains to take few lectures on functions from sets, relation and function chapter. So I will take 2-3 more lectures on functions, and with that we will complete our syllabus. Thanks for listening lecture carefully. Bye bye.